Here we go. Let's try a couple more challenges using our process to simplify some of these larger problems. So I don't see any zero exponents. I don't see any sprinkling or parentheses with exponents outside. I do see some negative exponents or traders, things that are on one side of the fraction bar and actually belong on the other. Those are things with negative exponents. So these two are negative exponents. Again, that means that they're on the top right now, but they need to go to the bottom. So I've circled them. I'll make sure I'll take care of them in a second. So let's write down what actually belongs on the top. 2x to the third. There's no traders. There's no negative exponents on the bottom. If I saw some, I'd move those to the top. I'd move those to the other side of the fraction bar. On the bottom, I've got 6x to the fifth, y to the ninth, z to the third, and then I've got y squared. So I moved it to the other side and made the exponent positive, and z to the third. All right, cool. I've done that step correctly. Now then, from here I can apply the product rule. I see that there are some y's there and y's there on the same side. They're on the same side. They're like teammates. They're combining up to help each other out. We have 9 y's getting multiplied together here in red, and 2 of them on the same side of the fraction bar in black getting multiplied together. So that's 11 y's. Now I put some space there because I still need to bring across the 6 and the x to the fifth. And then here I have z to the third times, this is all multiplication, so I'm taking the z to the third times this z to the third, and we add our exponents. There's 6 z's getting multiplied together on the bottom. On the top, I've got 2x to the third. Now I've got the quotient rule. If we see variables, or the same base, same bases on both sides of the fraction, they're battling. So right here we have a battle. Who's going to win the battle of the x's, the top or the bottom? Well, the bottom has more. So the bottom's going to win that battle. The bottom will have the x's. How many more does the bottom get? Well, the difference of 3 and 5 is 2. So there's x squared on the bottom. We still have this y to the 11th. There's no y's on the top that take out any of the 11 y's on the bottom, and there's no z's on top that take out any of the 6 z's on the bottom. Now we do have this 2/6, which reduces to 1/3. And because there's nothing else on top, that 1 has to be there. Let's try, one more. Can we do this? Yeah, we can do it. Apply the zero exponent rule. I don't see anything raised to the power of 0. Apply the power rule. Ooh, we got lots of power rule here. Trickle, trickle, trickle. Sprinkle, sprinkle, sprinkle. 3 sprinkles there. And on the bottom, I've got the -2 going to those 2 factors. No sprinkling over there. So what do we get? 2 to the third, x to the third, y to the 6th, times 3 squared, x to the 4th, y to the -6. Go back in 2 minutes. Thanks. On the bottom, we've got 5x to the -4, 2 to the -2, y to the -6. All right, we've applied the power rule. Now let's apply the negative exponent rule. Those are the traders. Do we have any traders on the top? Trader. Any traders on the bottom? Trader. 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 Holy moly. So on the top, I am excited. I'm writing really big. I'm going to have to start writing smaller. On the top, we've got 2 to the third, which is 8. We've got x to the third, y to the 6th, 3 to the third, which is, or 3 to the second, which is 9, x to the 4th, we've got this x to the negative 4 on the bottom that needs to go to the top. Oh, by the way, did you notice I didn't write this down because this doesn't belong on the top? It's going to go to the bottom. So this x to the negative 4 on the bottom goes to the top, exponent becomes positive. This 2 to the negative 2 goes to the top, so it's going to be 2 to the positive 2 now on top, which is 4. And then can I make it? This y to the negative 6 right here goes to the top, and it's got a positive exponent. Woo. On the bottom, we've got 5, and we've got this traitor on the top that belongs to the bottom, y to the 6th. All right. There's a lot going on the top. Let's clean this up. So this is all multiplication on the top. We can multiply all of the coefficients or numbers together. We have 8, we have 9, we have 4. So that equals 288. Did you know that? Double check it. Maybe I used my calculator wrong. So we got 288 on the top with the numbers, and then our x's. Take a look at our x's. We've got x to the 3rd, x to the 4th, x to the 4th. When we're multiplying the same bases together, we add the exponents. So that's x to the power of 11. And then we have y to the 6th and y to the 6th. That means we have 12 y's getting multiplied together on the top. On the bottom, there's no product rule we can use here. We've just got 5y to the 6th. Now, is there any battles? Are there any of the same bases on the top and the bottom? You bet. Right here. There's y's on top and y's on the bottom. So I ask myself, who's winning that battle? Are there more y's on top or more y's on the bottom? There's more y's on top. So our y's on the top get to stick around. How many more of them are there? There's 6. So we also have 288x to the 11 and 5 on the bottom. There's no x's to battle the x's on the top. And this 288 divided by 5 we can't simplify. So there we are.